we are going to do two exercises today. One is the FE analysis of this wing nut. Alright, so first we'll create a model and then we'll do the FE analysis. And second will be FE analysis of this PET bottle, okay, plastic bottle. And so we'll do meshing using the shell element. So we'll see both these examples. Let me just close down. So let's start. Go to part design. Tasks. New. Click on create body. Create sketch. Select the XY. Click OK. And now use the polyline option and just make an initial rough sketch, just like I am doing on the screen. So start with here. 1, 2, 3, and toggle M and make it circle. 4, again straight line. 5, 6, and 7, and then give the dimensions. Tangent, both the lines are tangent to the circle. That just alright. So these are all the dimensions. Everybody done up till this?
So one.
Take your time. Don't rush. Do it properly and calmly. Once you are done, just let me inform.
So how much is that distance? 11 point.
11.5. Yes.
Done.
Done. Everybody's done. How many of you are done?
No, sir, just
Yeah.
one more
How many
minute,
of
sir.
those are done? If you're not done, please inform me. Because this is a slightly complex. Done. Can I go to the next step?
Yes, sir.
All right. So close. So it is fully constrained. Close this and go for padding and change this to 23 millimeters and symmetric to the plane. You can also go to view and click OK. Go to view and do this toggle axis. So when you do symmetric, this toggle axis comes in the center of the uh, path.
So what is the thickness?
23.
Okay.
Make sure you check the symmetric option. Alright, done after this. So next, select this plane, okay, and create sketch on that. Okay. And now to do this, just toggle off, and we are going to import some lines for construction. So import this and this line, right? And then toggle it off. So these two are construction line, and now again select the polyline option and construct a polyline just like I am making on the screen. Make sure it is closed and select this point, this line, and give this a distance of 9.5 mm. Click OK. Right, and just drag on this corner and make sure that all the lines are getting dragged. Okay, we want it constrained in this manner as it is shown. Done.
Yes, sir.
Okay. All right, and make sure that you place this, make this what do you say, polygon, the perpendicular part. Make this as high. This is a little bit higher. Don't keep it too short. Just extend it like this. Just as I have done. Okay. Close this and go to group and select the y-axis and change this angle to 82 degrees and click OK. Done.
Yes, sir.
Alright, now next there is this mirror option. So go to this, create a mirror feature, select the groove, click OK, right, and select the XY plane, and you should see that the features are now mirrored on both sides, and click OK. Done up till this.
Yes, sir.
Okay. Now we are going to create a reference plane. We're going to add some more features to this uh, model. So select this line and then click on the datum plane. So a datum plane is generated normal to the edge we just selected, and click OK. And select this plane and insert and do this sketch on. Then go to the line and draw a line from there and view the angle this tool as 1D. Right. Now complete. Now select the polyline option and just close this polygon. Straight, horizontal, and closed. And just pull on one of the corners so that everything check that everything is a closed polygon. Done. If anywhere is stuck anywhere, let me know immediately. Just click on this angle. Just want to see it clearly. Alright, done.
Yes, sir.
Okay. Now let's go to the next step. So close this and select the groove option. No, no, so not the groove option. Sorry. Select the pocket option. Change this to symmetric to plane. Dimension through all. click OK. You see this, it has cut it in a incline. Done.
Yes, sir.
Okay. Now again we are going to mirror this feature. Select the pocket, click on the mirror option, and select this as the XY plane so that this feature is mirrored on both the sides, and click OK. Done. Now if you want, you can switch the datum plane off. If it is creating clutter, just hit the space bar. Alright, done. I guess you're done. So click this, select this plane and click on create sketch and go to this circle and create a circle at the center and give the dimension 6. Okay, and then close it and go to this pocket option, change the dimension to through all and click OK. Done.
Yes, sir.
Close all this and select the body and here change it to draft. Okay. And here you will find that menu for array. So select so drop down on that and select the polar array. We set this number of elements 2. Now if you want to switch off this grid, just click here, that will switch off the grid. We set polar array, number of elements 2, reset to 0 and click OK.
So can you repeat this step?
Okay, let me just repeat this. Click on body, then go to this array option. See, drop down. By default it is this orthogonal array, that rectangular things. Okay, so instead of that, go and select the polar array option. Right, and click on polar array, and this dialog box will appear. So make this to 2 and make sure that you hit this reset, and this all these values are 0. If you move around the mouse, then the values changes, so make sure it is 0. Okay, and if you want to switch off this grid plane, click on tab, come on the screen to reset and OK. Done up till this.
Yes, sir.
Okay, now go to this axis option and change y to 1 and z to 0. Right. So these two halves are now aligned. Done.
Yes, sir.
Everybody is done up till this. This is slightly tricky. Alright, now change this from draft to part. Click on this and create future. Right, after that change this to FEM. And at this stage I want all of you to save this part. Let's create a folder. Let's call it wing underscore and click save. Right. So our model is created. Now we are going to do the FEA. Alright, so as always for FEA, we are going to start with the analysis option. and you have the solver, calculate X, and select the material, change it to calculate X steel, and change this to, so you can change this property. Yesterday I used the MATLAB material editor, sorry, FreeCAD material editor. Now today I'm going to use the task panel. Select the task panel and change this to 100, and Poisson's ratio to 0.35. Click OK. Alright. Then we are going to give some constraints. So add, select the inner face, click add, select the other inner face, again click add, and click OK. So the it is constrained on the inside. Then we'll give some forces. Select the force option, select the face, click add, give this 700 newtons, and reverse the direction. Okay. And click OK. Now go to the other side and select the face on the opposite side. Again go to forces, select the face, click add, change this to 700 newtons, reverse the direction, reverse it, and click OK. Alright, done.
Yes, sir.
Alright, so select the fusion top option and click on Gmesh and modify this size, max element 2.5, minimum element 1, click OK, refine the Gmesh, select this 4 edges, corner edges, 1, 2, side, 3, and change the maximum element size 0.6. So in this way you have control over the mesh. Now double click on Gmesh and click apply. Alright, so model is meshed. Click OK. Then go to the solver. This part is done. Meshing is done.
No, sir. Just 1 minute.
Okay. I'll wait. I'll just come back in a minute. Alright, done with the meshing.
Yes, sir.
Okay, now click on this solver. Right, click on write input file. Write completed it says. Then run the calculix. Okay, so calculix has run. Close this and click on this, and then you can do your FEA. This shows you the magnitude of displacement after displacement. And change this factor and is this. Now if you want to avoid the clutter, close this model, appearance, make this transparent, make this 100% transparent. Then go to the result sets and do your FEA. Now that model part will not clutter your result. You can select the slider, set it to 2 if you want. Five. How much you want to see the reflection there. According to you can change it. You can see the one misses, maximum principal stress. Okay. Or and you can also do the pipe result. Select surface, select displacement, shows the displacement at various portions. Also go for the stresses, one misses stresses. As you can see, the maximum stresses are at the corner. Okay. So you can again, I will like to save this file, save as wingnut model. Let's call this as linear. here we have chosen the linear properties. Now let's close this and again open our model, that is the wingnut model. And now we are going to do the analysis by using the non-linear model. Okay, so select analysis, and then your solver is getting included. Then select the material, select your steel calcula X, calcula X steel, change this to 100 gigapascal. Point 35.35 and click OK. So expand on the ANSYS model, then select the material and then click on this non-linear option, then select this, and then we are going to define the yield points of the material. Okay, so this is, let's make this as 125.0, 180, 0.025 and 195.005. Right, so we have introduced a non-linearity in the material. Okay, so in earlier case it was linear, and now we have introduced non-linear. Many times you need to do a analysis which has a lot of non-linearity in the material. Now again we are going to define the same boundary conditions. Select this, add, and select the other piece and add, OK, and then again select this force, select this face, add 700, and reverse the direction, and OK. Then select this, then again go to the force, select, click the face, click add, change to 700, again reverse the direction and click OK. Boundary conditions are given, then go to the fusion and click on G mesh, do this 2.5 and 1 and OK, and then refine this mesh by selecting the 4 edges. Okay. So this model, we'll click on this edge. Okay. And change this to 0.6 and click OK. Double click on mesh and click apply. Alright, so the solid is meshed. Then click OK. Go to the solver, double click, write input file and run the calculator. Everybody with me on the same page? How many of you are able to complete up till this? Please raise your hand in the chat box so I can get some idea.
Sir, can you show that non-linear material again?
Non-linear material. Just a minute. Let me
Thank you,
complete
sir.
this calculator. Yeah. Okay. Okay. See here. The yield points you wanted, no?
How did you get this option, sir?
Just select on material, select the material, and there is this icon. See here for non-linearity.
Oh, okay, okay.
So once you define the material, then when you highlight this material, click here, then this will become active. Then click on that.
Okay, sir.
And then you can define the what is it, the yield points. This is going to take a while. All right, so finally the results are loaded. You can close this and then go to this last one and see the post processing. All right, see the stresses, and you can also see the difference in the mesh. Since we refined the mesh, the critical areas are getting meshed properly. Okay, so this is the where there is a joint, that is the critical area. You can see the displacement. This is, as you can see, the more critical area is shown with that red color. All right, close this, then go to the result pipeline. Select the surface option, select field displacement. It shows you the displacement. Okay, the legend is over here. It will also show you the stresses. See, the more critically stressed areas are shown in this red color. All right, that's is the first exercise for today. Any questions before we go to the second one? Can we go to the second one?
Yes, sir.
Okay, so let's go to the second one.
So why are there so many results here? But
Why are there so many?
results like time 25, 5, 75. Like lot of them are loaded. Like normally
Where?
we have only one tab, right? Like
No,
in
there
mod.
are this because there was what do you say, non-linearity. There are a number of iterations, so we are. It's not a user-defined. It is whatever the software. It is internally it thinks, it calculates, and it creates that sub steps. You are seeing this all these sub steps, no? Results. So
Yes.
these are the various sub steps in the results which it has plotted. If you see the what do you say, where will be, uh, go to this. The calculi X. See, this is 1 to this one. Okay. So earlier, in case the results were like done very quickly, but here it took a lot of time. So the various substeps were in. Okay, one thing I forgot to tell you. I should have shown it you when we chose the linear option also. See, as you can see here, the geometry. Let me expand this. Since we defined the material as non-linear, see it by the software itself picked that up, and it made the geometrical nonlinearity. Here there are two options: linear, non-linear. It by itself made it non-linear. Okay. Similarly, the material also, here you have a choice of choosing whether it is a linear or non-linear. But since we define it as a non-linear, the software itself picks it as a non-linear material. Alright, so that is the good thing about it. So whatever we have set over here, it is picked by the solver, that you can observe here. All right, any more questions before we proceed to the next one? All right, so let me close this. Let me save this. Save as and it is non-linear. Anybody has done non-linear analysis in any of the software that you are using? During your what do you say, car manufacturing and all, there must be some non-linearity na, in the material. Have you taken that into account, or do you just take it as what do you say, linear and do the analysis? Okay, so let's start with the next exercise, and here we are going to go to the sketcher and create sketch on the XY plane, sorry, XZ plane. Click OK. Right, now select this polyline option and select this, make a rough sketch like this of the bottle. Horizontal line, horizontal, vertical up, again incline, vertical up, incline, straight up, and straight, straight. Alright, then we are going to give the dimensions. Okay, going to give this and this vertical 5 mm. Just drag this out, this 30. Then select this one, this point, and this point, and give the vertical dimension 85. So move this a little bit. Okay, give this, make this as 40. Okay, again adjust this. Okay, make this and this 15. Okay, 20. Again, move this up. This and this. 30. Okay. Now we'll give the horizontal distances. First thing, we are going to make these two equal, 1 and 2, and apply the constraint equal, 1 and 2 equal. Then select this and make this equal to 10. Click OK. And select this, make this 30.
So how much is the topmost distance vertical?
Wait a minute. It is 11 mm. Select this, horizontal 32. This horizontal 27. Okay. topmost horizontal 11. And then move this point to the origin. So select this and select the origin and make it coincident so that the whole figure shifts up. Okay. Let me just adjust all the dimensions so that they are visible clearly. Alright, so these are all the dimensions. Once they are done, let me know. I'll come back in a minute. Okay, so the figure is fully constrained. Done with this, all the dimensioning. Can I proceed?
Yes, sir.
Okay. So to close this, and then we'll revolve this section. So to revolve this section, go to part, and there is a different revolve symbol over here. So select that. So just keep everything default and click OK. Right. That is the shape you have it. Okay. Now just we're going to make a fillet. Keep on selecting all the edges. Hit the control key. Change it to wireframe 1, 2, 3. The fillet option and change it to 5. Click on OK. Right. And change it to as is. See the fillet being done. Now we are going to make a duplicate of this part because we are going to use it for creating some feature. So select that, go to part, create a, and click on create a simple copy. Change this to wireframe and then select on this cylinder. Okay, so by default a small cylinder is created. Double click on it and we are going to modify the properties of the cylinder. Cylinder. We are going to change the radius 10, height 200. So as you can see the cylinder has appeared. Okay, click on the cylinder and just drag this little bit up. Data, placement, go to axis, axis, change x to 1 and z to 0. X to 1, z to 0. Change the angle to 90 degrees. change the position. Y as 100.
So what all did you do in the cylinder properties?
Just delete this. Let's delete this cylinder. Let us do it again. Delete. Click on additive cylinder. Here, change the radius to 10 and height as 200. Let's delete the cylinder and start over again. So 10 as radius, height as 200. Click on placement. Click on axis. Change X to 1. Change Z to 0. And expand the position. Change the angle to 90 degree. Okay, angle to 90 degree. And change the position to Y as 100 and Z as 100. All right, did you get it now? All the properties?
Yes, sir.
Okay. So the cylinder should appear in the center like this. Okay, because we are going to create areas to apply forces on the bottle. Everybody with me on the same page? Okay. Can just change it to as is, and you can see the cylinder is placed. As you can see, a copy was created by us, right? We created a copy. So we are going to use this and use the cutout option to create small areas for applying the force. Okay. So select this cylinder and fillet and select the cutout option. The cutout option. All right. So these small areas are created that we use to apply the force. Everybody is getting this? You can switch off the original and you can see the areas which are created. Right, now select these two and create Boolean fragments. And select on the Boolean fragments and change it from standard to comp solid. Standard compound solid. And select on the Boolean fragments and run the geometric check. And check. Expand this. So you can see that solid is 0 and comp solid is also 0. So we want to change that. So to do that, we're going to make some modification. So close this. And select the Boolean fragments and from part select compound and select the compound filter. And select this and again run the geometry check. And so now it shows compounds is 1. And still it is way. And shells is 1. Okay, so we want the shell. All right, change to FE. Right now again We are going to repeat the similar steps. Click on analysis. And click on material. Change this to calculi. No, not calculi. Change this to ABS generic. Change this to Young's modulus to use the task panel and change this to 2820. Change the Poisson's ratio to 0.
So how did you change that?
Which one? You see this, check this box, use this task panel option.
Okay, okay.
There are two options, use the material editor and then the task panel. So use the task. Yesterday we did, even the earlier exercise we did with the same option, task panel. And change the density. And click OK. Right. We'll give some boundary conditions. Select the displacement option. Click on add. And change x displacement in x, y and z direction to fixed. And click OK. And we're going to apply some force. Select this area, click add and change this to phi and reverse direction. And repeat the same thing on the other side also. Click OK and go to the other side. Select the area, add and phi, reverse direction. Okay. Alright, done up till this. Now select the shell mesh option. Select here, change this, add and select the top area and change it to 1. And click OK. Again select the mesh option, shell mesh option. And add all the areas, all the remaining areas, one by one. Add. Okay, so add all the areas.
So did you add the area where the forces were also there?
No, so that has to be added. But just a minute. And now add the points, areas where the forces were there. And change the mesh thickness of the element to 0.3. 0.3 and click OK. Select the topmost, that is the compound filter, and run the mesh. change max limit to 5 and click apply. Alright, so the meshing is done. And let's just inspect the mesh. Alright, so some discontinuity is created in the mesh. Alright, so we don't want that. Okay. Check the areas where the forces are applied. Alright, so there is some discontinuity at that. So I'm going to refine this mesh. Okay, so let's go close this. Analysis. Mesh. And I'm going to refine this mesh. And add these 3 areas and other one also. Add both the areas. Okay.
So can you repeat this step?
Just a minute. Let me just complete this. Change it to. Okay, so let me repeat what I've done. So after you have created this mesh, double click on this, select this mesh and select this refine mesh option. Okay, so when you click on this, you will get this dialog box, the mesh region dialog box. Okay, so in the mesh region dialog box, click on add and click on these 3 areas. One, this is second, and this is the opposite side one, the third one. All right, so all these 3 areas should get added and change the maximum element size to 2 and click OK. Done. Right, then again click on the FM mesh and click on apply. Alright, so can you see the difference now? Hello. So as you can see, we
Yes,
have
sir.
refined the mesh in the area that the force is applied. Okay, so it says that the clean run of Gmesh. So and we can observe that uh, quality of the mesh is much better. Okay, all right. All right. So I hope you have observed that. So click on OK, and then we are ready to run the calculi X now. So click on the solver, write input file. All right. So that is complete. Run calculi X. This is going to take a while. All right, calculi X is done. Results are loaded. Let's close this. Select this, and you can do the post processing. All right, and you can see all the stresses. Right. You can do one thing. You can just go here and just appearance. You can just make this transparent so that you can see everything. Select this and go to post processing. So now when you deform this, there is no clutter. Okay, can you see the effect? Oh, the bottle is squeezed when you apply the force. You can see the displacement. Okay, you can also do the pipeline. Select the surface and select displacement. Let's say it will give you the displacement, and it will give, can you find the stresses? So we have done the shell element. Use the shell element. You can use the shell element to analyze cylindrical pressure vessels. So with that, generally the shell element is used. All right, any questions? I guess we are done for today. Any questions you can ask, please? How many of you are able to do the exercises on your own? Okay, the feedback form has been sent. Or if you
Yes,
give the feedback.
yes, the feedback form has been sent on WhatsApp and MS Teams.
Okay. Uh, all right, is Vaishnavi still there in the?
Yes, sir. Yes, I am there.
You can start working on the brochure. Huh? I will tell you exactly what the idea is. But you have access to the you will that brochure you need to prepare based on whatever that activities I gave on the day, na, this course outcome for day one, this day two, that like that you can just prepare a brochure.
Okay. Okay. I'll ask sir
Yeah,
about
yeah,
it and
yeah,
start
yeah.
with it.
I will give some idea about it, and we can discuss with Pawan sir also. So that images for that brochure you need, no, that you can take it from the exercises whatever we have done. One or two image will be sufficient. Like just as a sample for per day, just take whatever, like arrange some sample images, whatever exercises we have done, and that way you can prepare a brochure. You can consult with
Yes, sir. Okay.
one sir, and maybe you can will also help you with that.
Okay. Yes.
Okay, so anybody else has
Understood.
any questions? If no
Sir,
question,
what to do if calculus execute error is shown?
has it shown error?
Yes, sir.
Okay, it should not show error actually. But like, are you getting this? See, sometimes there are some errors which are because of the geometry. So, but are you get able to do post processing
No, sir. While rerun calculus, I am getting calculus execute error.
for this exercise or which one?
This one only. PET bottle.
Okay, okay. What do you mean by rerun calculus? Did you like?
After writing after the right input file, we run calculus now.
Yes.
In that, I am getting in between all the calculus execute error.
But are you able to generate this CCX results?
Um, second. No,
This is not generated. Okay,
no.
that's strange. But have just try it once more. I don't know where you might have missed. Did you do the mesh region correctly?
Yes, sir.
Okay. Now, uh, were you able to run the solver?
Yes, solver 6x.
Sometimes what happens, just when you click on the solver, no, you should have to make sure that nothing is selected. Okay, just click on this blank screen like that, and then try it again.
Okay, sir.
What is the error that it is showing?
Uh, calculus X execute error.
Okay, that is not very clear. Anybody else getting a similar error? So I guess no. Or it should not happen actually if you do the steps. If you might have missed any steps, in between. Just go through the tutorial, because the error which is coming, it is not very clear what is the issue. All right. Let me close this task. Okay, this has to be closed, otherwise this doesn't get open. Where were you getting error? Here you are getting error, no?
Yes, sir. After the right input file, when we run calculus X, in that I am getting calculus X execute error.
Okay. Did you create the solver again, or you use the first one itself? Did you create
First
another?
one itself.
Okay. So that is strange. Have you made sure that you have chosen all the faces? This is what might have happened. Since there are so many faces over here, it is quite possible that you might have missed some face. Is your mesh appearing clearly? Is the objects uniformly meshed? Are you seeing areas or patches which are not meshed?
Sir, at the neck, uh, no, uh, at the top of the surface, there is a gray screen, the area which is not meshed.
That which one? This one?
Yes,
This area or
just below that, just
the
yes,
small
yes,
ring?
this,
Okay. So what might
yes.
happen? When you are selecting the areas, no, must have forgotten to select this area. That is why it is happening.
So, so what to do now?
So you can just delete the mesh,
Okay,
delete everything from the point where you are doing the selection for the mesh,
okay, sir.
and then do it again. Alright. Any other question? All right, we'll stop for today. Thank you. Fill the survey.